tell us a little about yourself,
Okay.
what your position is, and what you do at Rose.
Okay. My name is Mario Simoni. I am department head for electrical and computer engineering at Rose-Hulman Institute of Technology. I've been doing this for about 10 years now as department head and 20 years as a faculty member, 25 years as a
I was going to
faculty
say, it's
member.
got to be more than me because my 20 years right now.
Yeah, 25 years. Yeah. So it has been a while. Is that good enough or do you want?
No, what do you teach? Are you still
Oh,
teaching?
okay. I am still teaching. So when I first started teaching, I was focused more on computer architecture that morphed into signal processing and electronics. And now, more recently, I've been doing more design classes. So I've been teaching our freshman, junior, and senior and capstone design classes. And then as department head, I fill in wherever is necessary. So I probably taught about half the courses in the curriculum.
Oh my goodness. So you
Yeah,
know it all
yeah,
back to
I
front.
don't know it all, but
You've
but
seen it all.
maybe I've done half.
Okay. That's totally fair.
I've done half of it. Yeah, yeah.
So I'm curious, I wanted to ask you, where do you see AI being put into the curriculum from the perspective of teaching the students AI? Are you doing Edge AI?
Yeah.
Where's that being implemented now, specifically in the ECE department?
It's all happened so fast, right? We talk about disruptive technologies, and this has been a disruptive technology that's come on very quickly. Where I see electrical and computer engineering intersecting in this technology, um, we already have a number of courses at Rose-Hulman taught by the math department, the computer science department. So we have courses in AI and machine learning and deep learning and predictive systems and things of that nature. I think where electrical and computer engineering fits in is where you're going to put a control system or you're going to use sensing technology and you want AI to be a part of that. So if you have a feedback control system with AI interpreting sensor information, and now you have probabilistic feedback coming into the control system, and then you want to make a robust control system out of that. And so that's one aspect. When we talk about edge AI, where you have AI running on a microcontroller, right?
Yeah.
But microcontrollers are usually embedded into something as part of a control system. That's why they're called microcontrollers, right? And so it's that combination of putting AI on a very small processor, or it may not be that small, right? But because things like Raspberry Pis are running Linux,
Sure.
right? So it may not be that small. But when I hear you talk about even putting it on Pi Nanos and other things like that, you can't go to the cloud to do something like that, right? If we're talking about autonomous vehicles, and I can't remember the names of the taxis, the autonomous taxis,
Like the Waymos?
yeah, Waymos, that's the
Yeah.
word I'm looking for. Yeah, so like the Waymos in California. And it can't go to the cloud to figure out if there's a pedestrian in front of it, right?
Right.
So these algorithms have to run on very limited computing resources. And so understanding how those resources impact the algorithms and how the algorithms can be run efficiently on those resources, that's the intersection of electrical and computer engineering, right? With that technology. And so I think that's one place where AI is becoming a part of ECE, is that they call it edge computing, right?
Right. Well,
Edge
yeah, edge
AI.
computing, and then it's evolving into
Into
edge
edge AI,
AI. Now
yeah.
physical AI, and it
Yeah.
just all, yeah,
Yeah, all of
moving
that.
very fast.
Yeah. The other place where I think ECE has a very important role to play is in sustainability
Mm.
of AI. So we've recently, one of our faculty created a course on high performance computing and AI. The whole point is how do you develop massive computing architectures to efficiently run these algorithms? And when we talk about, in Virginia, 25% of the energy production going to data centers and AI, and people are really worried. Like, there are people very self-conscious about every time they use a search or go to Google. and they want to turn off the AI feature because of the sustainability issues and how much water, power, and energy. So I think there's a huge role to play. Computer science isn't going to solve that problem, right?
Right.
It's going to be electrical and computer engineers that solve that problem. So I think that's another key place. I think there's other roles to play. I've learned a lot at this conference about, what is it that students need to do with AI, and I see all kinds of interesting things coming out. We have now test systems that have agentic AI built into them, and so students are going to have to know how to have a conversation with this AI
Right.
when they're manipulating these systems. I think this is going to be an important thing to use to teach our students for the future. And there's so many other things that we just don't know are coming yet that are going to become a part of AI. MATLAB has Copilot built into it now, and signal processing. How are we going to integrate that with what students need to know with regard to signal processing? I think there's some key fundamental questions, though. How do we maintain the fundamental skills and knowledge while teaching students to use tools that bypass those fundamental skills and knowledge? And so that's where I think faculty are really wrestling with these questions, and they're hard questions. And so, when you say, where is AI going to show up in electrical and computer engineering at Rose-Hulman, that's where my hesitation is. There's a lot of caution, right? And a lot of hesitation that we don't want to throw the baby out with the bathwater, so to speak, right?
Like just say no AI?
Well, no, that we say throwing the baby out with the bathwater. I sort of mean the inverse of that, right? That if we just dump AI into everything,
Oh, right.
what are we losing in the
Yeah.
process of doing that, right?
Well, you had a good point about students, not doing well or doing all their homework super well and then failing
And
tests,
failing
and
tests.
losing the fundamentals.
That's right. Yeah.
And so have you, being at the conference, have you had any good ideas
Oh,
or
gosh.
talked to some professors about what can be done to help students make sure they're learning those fundamentals and testing them so that they're not bypassing them with something like ChatGPT, but then still giving them the opportunities to use these tools so they're ready for industry?
I don't have those answers.
Yeah, that's
right.
I mean, it's a tough one. It's
I
what we're
don't-
all wrestling
And
with.
anybody who says I have all the answers to that, just do what I tell you to do, is lying, right?
Right.
Because but that's what we do. We're educators, we're innovators, we're engineers, right? We need to engineer solutions to this problem. I think there's a hesitation among some faculty to say this is going to ruin learning, and so, but yet it's coming, it's here, it's
Right.
being demanded by industry. If we don't do something with it, we're also leaving our students behind. So if we dive in and just give them free reins with AI, we're leaving our students behind because they're not learning the fundamentals. If we say no AI, we're not going to teach you how to use it at all, then we're also leaving our students behind, and they're not getting the skills, and we're not giving them the opportunities that to seek employment in industry that is demanding these skills. So I think there's I don't think there's any one good answer, but I think at the fundamental level, freshman, sophomore level courses where they're learning the foundations of the fundamental knowledge of engineering, we need to restrict AI use.
Yeah.
But then as they become more proficient, then showing them how to use it effectively. I think some of the phrases that I've heard at this conference that resonate with me is that AI is a skill multiplier.
Right.
But if you're multiplying 0, you get nothing,
That's a good one.
right? Right? Or if you're multiplying a negative number, you're growing in the opposite direction, right? So we have to ensure that students have something that they can multiply. And when we're asking them to apply it to problems where they're multiplying something they already have, then it's a good place to try and fit that into the curriculum. where we're asking them to learn something for the first time, it's a very poor place to put that into the curriculum. The problem is knowing when is what, when is the right time and when is the wrong time. And those are things we're going to have to learn over time. We're going to have to innovate on. Developing new techniques for doing that is going to take time to innovate. I think it's also troubling for students. It's very confusing for students because they go to internships, and on their internships, they're being told, plug it into AI and get the solution as quickly as possible. And then they come back to academia and they're being told, here's your job, get your homework done. Well, I got to get it done as quickly as possible, so I should use AI. And they think they know what they're doing because they see what's happening in industry, but they don't have the experience and the maturity to understand the context in which they're applying it and what it can and what it can't do for them in the long run.
Right.
It's very, in the short run, yes, it can get your work done for you. But in the long run, if that's what's getting your work done for you, then you're not developing the foundational knowledge to be a successful engineer, to have something greater than 0 to multiply, right? So they just don't have that perspective. And so these are just all the things we're wrestling with. But coming out of this conference, I have seen potential for basic skill sets that we can teach students. Learning how to work with an agent, how to talk to an agent. We say talk, this is anthropomorphic, but how to communicate through an agent to make a machine do more work for you than you would have been able to do without it, right?
Right.
And do that in an efficient way. It's going to be a learning process.
Yeah, for sure.
And finding the right situations in which to do that, finding the effective ways to do that is going to be tricky. But I think, coming to ECEDHA again this year after last year everyone was clueless. We were just, AI is going to do everything, but nobody had any idea what that meant. And now I'm starting to hear some frameworks of what that could mean and how we could potentially teach students how to use it effectively, right?
Yeah.
Whereas before it was just kind of, well, throw it at them and see what they do and see what they can come up with. Well, they're great optimizers, and so they're going to optimize their workload, right? But that's not optimal for their learning necessarily.
Right, and not really preparing them for the workplace.
Yeah, and we didn't even know what it was they needed for the workplace, right?
Yeah.
So how do we figure that out, and then how do we figure out what they need for the workplace, and then how do we figure out how to help them develop those skills and that skill set? And I think we've got to do faculty development.
Yeah.
Because without faculty development, we're not faculty. This hit them like a ton of bricks, on a Sunday morning, and they have no idea what hit them. And now they're being expected to teach something that, one, they don't necessarily agree with, they don't understand, they don't know how to use, and they're being told it's necessary to teach it. It's a very uncomfortable position to put a lot of faculty in. So,
yeah, and it's changing a lot of it on its head.
Yeah.
Like, oh, you could use computers on your tests,
Yeah.
how do we make sure the students aren't cheating?
Yeah.
If you're really trying to test their knowledge.
Yeah.
And that's a tricky one. And so something I'm hearing from some of the folks I'm talking to at the conference is they're going back to old blue book style, pencil and paper, and it's
oral exams.
Or oral.
Not even pencil and paper.
Yeah, oral.
But you have programs with 4,000 students. They can't do oral exams. It's just not a possibility. So, hard questions.
It's tough. We're back to hiring tons of TAs to help with the grading, right?
Well, but a TA can't do an oral exam because it's very subjective.
True.
Right? And pencil and paper exams can be done, and TAs could potentially help with that. But then, do you have undergrads grading undergrad classes and exams? And if the entire grade now is based on an exam, do you allow other students to grade? That raises conflict of interest questions.
Right. Well, does Rose still have TAs? And CS had TAs. I think the ECE department had some grading assistants.
We have for homework.
Right, but the exams were always done by the
Always
professors.
by the professors,
Right.
right?
So that's one model.
Yeah, and the labs, we have TAs help us in the labs.
That's right.
Right. But always under the supervision of a faculty member. But yeah.
Yeah, it's a tricky problem, and it's like, we're going back to these non-scalable methods. You're thinking, oh, AI is going to be able to help us, and then you realize anytime I can apply AI to help me with the curriculum, or not necessarily the curriculum, that's a different story, or the teaching aspect, that means the students are going to also optimize and undercut their learning.
Right.
So we're going back to these methods of, pencil and paper, because you can't use these tools. It's like, learning to do math before using a calculator.
Yeah.
So when do we add that tool in?
Yeah.
So
yeah, I think a reasonable method at this point and where we're at now is, to really, really restrict usage of but AI is a broad term, right? So we want to restrict usage of LLMs and anything that any sort of agentic interaction in the first and second year for required work, right? But as they get to be juniors and seniors, now they have some knowledge that they've developed, and they can apply agentic interaction to help solve problems that use that foundational knowledge.
Right.
Right. But again, if they're then learning an advanced course where they're really digging into new material for the first time, they're not going to be using agentic interaction again to learn that material. So now you've got a situation you're putting students in, well, okay, you can use it here, but you can't use it here. And it can be very confusing for them. Like, can I use it or can I use it?
Yeah.
Right.
Well, maybe. I mean, there were classes I was allowed to use calculators, and then I'd move to another class, and we weren't allowed to use calculators. Like, we had Maple, and then not Maple. And then, so, the tools come and go.
Right.
And so it's like, when do you interject those tools into their learning path to help them the most?
And that's where it gets back to faculty experience.
Sure.
Right. And how do we explain this to students? How do we help faculty develop arguments to help students understand? How do we give faculty experience so they understand what they're trying to do and what they're asking their students to do? So it's a like I said, it hit us like a ton of bricks on a Sunday morning. And so now we're trying to keep up as best we can. And
yeah. No, I think you had some good pieces of advice and things to think about for, other schools and faculty to consider.
Yeah.
So thank you so much, Mario. I
Thanks,
appreciate
Sean.
your time.
Appreciate your questions.
Yeah.